sometimes a question is going to tell you the percentage or the probability that something has happened. So remember, all of those other questions we've just been doing, they've been saying, what's the probability that this event is going to occur? Okay, so has the value been greater than, has it been less than, what's the deal? And so those decimal values have been the probabilities of those events. What they're doing now is they're going to say, well, this is the probability, what value is going to give us, what value have we been considering in order to get that probability, okay? So, I've said it's always handy to do a sketch still, okay? Because you know that if the decimal value that they've given you is, for example, 0.73, you know it's more than half of the diagram. If it's only 0.024, it's less than half of the diagram. Okay, so have that in your mind when you're doing it. Now, the area that you're entering must be the area to the left of the value you're finding. Now, you may be saying, what on earth is she on about? Okay, but it's important that the calculator is looking at the area from the very left up to the point that they're looking at. I've repeated it and I haven't actually made it any better for you. Alright, it's best to go through an example. A. So they're saying we need to find this number here. Now notice we're still talking Z-scores. Okay, so these questions are based on Z-scores, they're not based on real life problems, but we could be doing them for real life problems as well. But these ones are Z-scores. They're saying that we need to find this value that would have given us a probability of 0.877. So I'm sketching my curve. I'm putting 0 there. If my probability is 0.877, and remember that we're measuring it from the far left, where will my line end up with my A on it? Is it going to be over here? Is it going to be over here? Where is it going to be? Over here. You all happy with that? And it's probably quite far over there because it's 0.877. Okay, so it's the good majority of this diagram. So this is the value we are trying to find. We're saying that this area is 0.877. So where before we went into distribution and we looked at normal CDF, underneath it has in normal, okay? In normal. All right, cheapisms. So that's what we're going to do. And what it says then when we're putting stuff in is it asks for the area. And the area that we're going to type in is 0.877. And these are Z-scores, so it's going to be 0 and 1. Okay? So do I need to show that on the calc? No, you're good? Perhaps I'll do 1 just for the crack. Oh, I've lost him. Oh, Dr. C. Oh, I didn't even see your response. You're wonderful. Oh, everyone knows that.
I knew too.
Okay, so what did we say it was? 0.877?
Yes.
And then 0.1, 1.16. Okay, so A for this one is 1.16 transponders. Easy? So far, so good. Okay, B. Now, here we've got our value of A. The probability is the probability that our thing is greater than A is 0.2. Okay, so the fact it's greater than A is only 0.2 tells us that A has to be over here and that this portion here is 0.2. Are you happy with that? So the probability that my value is greater than A is 0.2 means that my A has to be on the right hand side, because this little portion here can only be 0.2. Yeah? If this number had been, if it had been greater than A and it was 0.7, then that would have meant my A was over here, because the greater than part would be more than half. Yeah? Now, what did I say though? In the calc, what do we input? No. We're the area to the from the far left. Okay, so if we're having to input the area from the far left, we're not going to be entering 0.2 in our calc, are we? We're going to be entering this portion here, which is 0.8. Okay, so you must enter area from far left. Okay, not from the left of, not the left of the number that you're interested in. Well, anyway, it's not looking at the value, it's looking at the actual area. So if we were to do that, again, wrong button, Miss H. So inverse normal, so we're putting 0.8. And we've got 0.842. So far, so good. Now, this next one is a little bit different.
Oh Lord. Oh, do we times them by 2?
Well, oh my gosh, you've got the right idea, but obviously those ones where we did multiply it by 2, but this one we're actually going to halve it. Because if we, awesome Olivia, we've got that on tape.
Your favorite is student alone, right?
Exactly.
Yeah, like as well.
Alright, so if we're saying that the probability of something happening is in between two values, so we've got the negative A and positive A. The A represents the same number, so it's not going to be negative 0.1 and positive 8.2, okay? The A has to be the same number. So it has to be symmetrical. So that would be A, sorry, on the right would be A, and we'd have negative A over here. And we know that the total area of this would be 0.42. Again, we have to find the value, we have to enter the area from the far left. So at this point we can choose. I would suggest probably trying to find the negative one, okay? Which means we need to enter this area here.
0.29.
Pardon? So what we have to do is to establish what this portion here is, probably, is the best way of doing it. So what would the black part be? No. 0.21. Why is it 0.21? Because it's half of that, yeah? And then if I wanted to find the green, how am I going to do that? What am I going to subtract it from? If I want to find the green, if I know the black here is 0.21, what do I know that this...
Oh, from 50.
Yeah? No, you did. Oh, no. Darn it. Olivia? You'd subtract it from 0.5, because we know that from this line to the left is 0.5. Yes? So to find the green area, we're going to do 0.5 subtract 0.21. 0.29. Good mental maths. What did you say? Awesome. Okay? So we're now going to enter 0.29 into our calc. Oh, let's see if we can get it. Oh, it's going to take a while. So, excuse my stance. 3. So, 0.29. And as we expected, it's a negative answer. Okay, it's negative 0.553. which means that A itself is 0.553. Okay?
Wait,